So this first section in chapter 2 is a way to help organize and also display your data. So we're going to start getting into, we talked about surveying and collecting data, but we didn't actually collect any data. Now we're going to have it as if the data has been collected, and we're going to put it in some type of order to try to make some sense of it. Okay? We're going to look at, in this section, we're going to look at frequency distributions, or sometimes known as frequency tables. Okay? What does the word frequency mean to you? Physics? What about physics? Oh, you're talking about like sound frequency? Okay, that's one type of frequency. That is not this type of frequency. What's another type of frequency? Yeah. How many times something happens? That's exactly what this is. Okay, so that's what this data is going to be. Okay, we're going to take raw data, and raw data is just the data. Okay. And we're going to put it into a table. We're going to come up with classes, and I'll explain what that is here in a second. And then frequencies, the number of times that particular data comes up, the number of times it happens. That's what we're trying to do with the frequency distribution. Here's an example. This is on page 37 in your book. If you want to take a picture of this screen, or if you want to screenshot from your book, you can. I just want to show you what it kind of looks like. Basically, a surveyor or a researcher was collecting data on some topic. I don't know. It could be temperature. Maybe these might be temperatures over the course of several days. And the researcher just recorded all the different temperatures at certain times and collected it. This is what's called the raw data. There's no sort of order to it. It's just a bunch of numbers. Okay. Now, to the right, you see a frequency distribution where they've broken it into class limits. Okay, or intervals is another way to think about what a class limit is. And then there would be so that'd be the first step, and I'm going to talk to you about how to come up with the class limits. And then you just go through and you go down the list and you check them off and you put them in the right column. All right, so that's that sort of hand work where you're doing the tally marks to find out how many, and then eventually we clean it up. And one of the things I want you to get in the habit of doing when you do make your own frequency distribution is coming up with the total. Whether you write it or not, it's kind of up to you at this point. But that way, what does that do when we total it up? What are we guaranteeing? Accuracy how? Why would I want to total them up?
Just to prove that you counted all numbers.
Yeah, exactly. To prove that I counted them all. Make sure I got them all. If this ended up adding up to 49, I missed one somewhere. And I'm just going to tell you right now, that's going to happen. Okay? You're going to skip one, and you're going to have a hard time finding it. So, when we get into a problem here in a minute, I'm going to show you a technique that I like to use that helps you not forget accidentally one of the numbers. Okay? How many of you have seen a frequency distribution or frequency table before? Okay, not many of you. Good. So this is new. Okay, so there's three types of distributions that we're going to look at. There's not just three types. We're just going to look at three types. Okay. The first one is called a categorical frequency distribution, and it's used for nominal or ordinal sets of data. Remember, those are categories. So, or rankings. You're going to be using words to... your data will look like words or categories, okay, instead of looking like numbers, and we're going to put them in categories. I'm going to pull another example from your book, and I'm only going to pull parts of it out. This particular set of data is about blood type, okay? And here are a bunch of different people's blood types. It's in page 38, 39 in your book if you want a screenshot. or you can take a picture here. You might want to wait just because I'm going to add something else to this screen here in a second. And really, I'm not going to go through and show you how to do this one. You know how to do this. But essentially what we're going to do is we figure out the different blood types. You've got A, you've got B, you've got AB, you've got O in this particular example. Okay, and all we're going to do is organize it. Find out how many A's there are, how many B's, how many AB's, and how many O's. And what it would look like is just this. Now, one of the things that I'm going to ask that you do whenever we do a categorical frequency distribution, I also want you to calculate the percent. Okay? Now, what's important about this, in case we are unsure of how to calculate percent, it always has to add up to 100%. And when you do your rounding, you have to be careful because sometimes when you round, you get more than 100% or less than 100%. So you've got to be careful that you're consistent there. All right? It's important that we have the total because in this case you would go 5 divided by 25, then multiply by 100. 7 divided by 25, multiply by 100. 9 divided by 25, multiply by 100. Okay. Or you could also multiply, because it's 25, all of these by 4. Either one of those work, okay? But you guys know how to find percent. This is an example of categorical frequency distribution because the data is not numerical. Okay? Questions about that? This one's going to be pretty straightforward. Okay? Alright, let's move on to this thing. The next thing is what's called ungrouped frequency distribution. It's called ungrouped because we don't use intervals. We don't use class widths. It's not categories. It will be numerical. You're going to use single data values for each class, for each interval, so to speak. It's not going to be an interval because it's just going to be one number. And we use this for smaller sets of data because there's no reason to try to simplify it. We can actually just organize that small set of data fairly simply. And the one that we're going to look at, that we're going to do together, is this data set. I made a nice little small data set for you. So, what we're going to do is we're going to create a distribution. We're going to create a table with all the values. And our first step is going to be, again, we've got our class, we've got our tally mark column, and we've got the frequency column. So what it's going to look like is this. Okay, and I went ahead just to save us time and did the tallying already. Okay, notice I didn't put anything at the 2, 3, or 4. How come I didn't put any tally marks there? Yeah, they're not there. There are no 2s, 3s, and 4s in the data set. Okay, so again, the class goes by a single number because it's a small set. It's not a big pain to have to write each number out. Okay. And then from there, all we have to do is fill in the frequency based off of what we got in the tally mark. So go ahead, you guys go ahead and do that. Finish that frequency column. So, here's what you should have gotten. Now, this is a case where you do have to put the zeros in. Okay? And I'm sure that was one of the things you were wondering as you were filling that out. Once we've established all the classes, we do have to put the zeros in just to indicate, look, they don't show up. There's none there. Okay? Should have been pretty straightforward. Now, one of the things that we can do from an ungrouped frequency distribution is create something that is called a cumulative frequency distribution. Okay? And so this gets built off of this. Okay? And what a cumulative frequency distribution does is it sort of gives a running total. And instead of... So this is, both of these are examples of ungrouped frequency distributions. The reality is this one can't be done unless we really have that one. And so what will happen is our classes will look like, instead of 1, 2, 3, 4, it'll be less than 1, less than 2, less than 3, less than 4, like that. So we kind of keep a running total, and so this is what it's going to look like. Okay? So essentially it's counting all the ones that come before the last one. And we'll work through this one together. And the reason it has less than 8 is because we have to include 7 in there. All right? And it's always less than the first value. Okay, our first value is 1. That's where we start. And the last one is always less than 1 higher than the last value. And it's always going to go like this for cumulative frequency distribution. Yep, and it's always less than, yes. Well, I suppose it could be more, but then it would all be opposite. You know, but for our purposes, we're going to use less than, okay? So what I want you to do is I want you to do the tallying for this, okay? How many are less than 1? How many are less than 2? How many are less than 3? And go down that column and fill that in, and then after you do that, you can come up with the frequency. What's going to be true about this last one, less than 8? They're all less than 8, right? So the total better be that one. Okay, so when you get to less than 8, it better include all of them. Let's take a look here, see what you had, if you had the same thing. Okay. Up. So as you go through this, notice how the numbers just keep growing, right? The number that is less than 1, there are none less than 1. So that first one's going to be 0. Less than 2. Again, it has to be less than 1, not less than or equal to. So there are none less than 1, smaller than 1. Less than 2, there's 1. Less than 3, how many are there? There's still only 1. So like until I get to 5, it's going to be the same. There's less than there's still that one value that's less than 2, less than 3, less than 4, less than 5. It's the same number every time. So it's not growing because there's that gap between 1 and 5. All right. So then when I go to less than 6, now I can add the 5s in. So less than 6 is the 3 5s and the 1, which is why there's 4 of them. Okay? Less than 7. Now I'm adding the 6s, the 5s, and the 1s. So there's going to be 8 of those, and less than 8 is all of them, and there are 10 numbers altogether. Okay? That's what a cumulative frequency distribution does. It just kind of builds as you move down the classes. Okay? And you're counting them as a group, so these classes get bigger, right? Because less than 1, there are none. Less than 2, there's 1. Less than 3, you're talking about 1s and 2s. Less than 4, you're talking about 1, 2s, and 3s. So we're actually changing the width of each class. So over here, the class is just one number. But over here, the classes grow. They grow from none to 1 to 2 to 3 to 4 different possible classes. So we're adding basically these classes together to come up with these frequencies. Yeah?
Why would you want to do that? Like, why would you want to?
So one of the reasons you would want to do that is determine how closely numbers are grouped together. Okay, one of the things that we're going to get into later in this course is looking at the spread of data and clustering of data. And oftentimes you interpret data based on how closely or how far away data is collected. And it means more. For example, you guys like to look at your test averages, right? Because you think that's an indicator of how hard the test was, right? How did the whole class do? And so what the problem is with that, if there's a huge spread, if there's people in the 40s and people in the hundreds and people have you look at a class average and you say, oh, 75. Well, everybody, okay, so there's some D's and C's and B's and everybody's right in there. But we don't know anything about the spread, okay? Because, if somebody gets a 40 and somebody gets 100 and I average those, we're looking at a 70 and you're like, oh, well, people are getting in the 70s. Well, we don't know that. We don't know about the spread of the data. It could be. And so one of the reasons we use a frequency distribution, it clearly tells me that I'm bunched up here because it grows really fast at this end, right? It's pretty light at this end. And of course we can also make that determination just by looking at it. But when we get a bigger set of data, it's going to be a little trickier. So that's a good question. Other questions? Right, so that's our second one, ungrouped frequency distributions. Within that we have a frequency distribution, and we also have a cumulative frequency distribution. The next one is a little more involved, okay? And the next one is called a grouped frequency distribution. And it's called grouped because each class is no longer going to be a single thing. Even for the categorical ones, it was just the single blood type. For the ungrouped one, it was a single data value. Now we've got a bigger data set, and instead of creating individual classes, each class is actually going to be a width, a class width or a class interval, like the very first example I showed you. Okay? The very first example had an interval for the class width. And so what we're going to talk about here is, one, how many classes do we have to come up with? How wide the interval should be and how to do that. And then once we have that, it's a matter of doing our tally marks and creating our frequency distribution again. But so what happens with the grouped frequency distribution, there's a lot of work that has to be done on the front end, and then once we do that, we just go and count them up like we did. Okay? So what I'm going to show you are sort of the steps first, and then we'll work through the steps together. Well, to some extent together. Okay? So here are the steps. First thing you've got to do is determine the classes, the limits, and the boundaries. So boundaries that we used in Chapter 1, we're going to use somewhat here in Chapter 2. The limits are the intervals. How wide our intervals are going to be. And how many classes we're going to have. That's going to be our first step. And obviously, I just named 3 things, so the first step has some nuances to it. The second thing that we're going to do is we're going to make our class widths, and we try to make them odd to ensure that there's a midpoint that is not a different decimal than what the classes are, the rest of the data. And I'll explain that when we get to class width and why it works. We'll talk about that. This standing by itself without data is a little bit confusing. Okay? When we get the data and we start working through to find the width, it'll make a lot more sense. I like to give you sort of a step-by-step recipe so that when you're going back to do it on your own, you remember, okay, I got to do this, then I got to do this, then I got to do this. And within each of these that I'm going to give you, we're going to work through them and walk through them. All right, the next one is you're going to have between 5 and 20 classes. Okay, the better the width, the better the spread, the more accurate gauge we're going to get of what's happening with the data. And again, statistics is all about trying to use data to draw a conclusion. Analysis. Okay. Between 15 and 20 classes. More often we're going to have between 15 and 20. More often we're going to have between 5 and 15. Okay. So we're going to prefer 5 to 15. But sometimes it's not possible. Okay? Our preference is between 5 and 15. Again, sometimes it's just not possible. 2 more. The classes are mutually exclusive. So there can be no overlap. And again, when we look at the example, you'll see what I mean. We don't want to have overlap of numbers. We don't want to have a data value that could be in 2 different classes. It's got to be in one class. And so when you create your classes using your class lists that I'm going to show you how to find here in a second, you'll see that it's impossible to have a data value in more than one place. But as you set up your classes, you just have to be careful of that. Make sure that that can't happen. And the last one, the classes must be equal in width. So this is a little bit different from that cumulative frequency distribution, because each class could contain more than one value. As we moved up, the class width, the size of the class, kept growing, because you kept adding another possible value that could be used. In a group frequency distribution, that's not possible. There will be no cumulative group frequency distribution, okay, because of the intervals that we're using. So these are the steps that we have to follow every time we create one of these things. And just use this as a resource so you know that you knock all of these things out as you're working through this. Okay. Now, let's look at a data set. Okay, this is on page 41 in your book, or you can just screenshot it. Or take a picture of it, is what I meant. So as you can tell here, we've got a lot of values, okay? This is the record high temperature in each of the 50 states in some year. We don't know the year, okay? Record high. I guess it could be any time. Over time. Record high can happen. It doesn't all have to be in 1 year. Holy cow. Look at some of those temperatures. Record high temperature of 134 degrees. Yikes. It's probably in Florida or Arizona, the desert. The first thing we want to do is identify the smallest value and the largest value, because that's going to determine our range. While we're doing this and determining how many classes there need to be, or the width of our class, because they tell us there's going to be 7 classes, which means you're going to have 7 rows in your table, okay? What we have to know is how to divide that up. How wide should each class be? Okay, so what's the smallest value up here? 100. Okay. What's the biggest one? I already told you. 134. So we want to identify our smallest and biggest, because that way we can figure out how big of a range we need to create. Well, how far is it there? It's like 34 degrees, right? So what I'm going to do is take that 34 and divide it by 7, because that's the number of classes, and that should tell me width. Okay, so here's what we're going to do is find our class width, and that's that 34 divided by 7, which is almost 5, which is good. Our class width is an odd number, which means the middle of each class, of each interval, will be a number of the same decimal place as all of this data, meaning the middle of each interval will also be an integer. I'm not going to have any 0.5s in there. If I would have had a class width that was even, the very middle of the data interval would be a something 0.5. So we like this. This is a good situation. Okay. So from there, what we're going to do is start our class limits, our interval. Okay. And so we start with the smallest value, which is what? 100. So it's going to go 100 to something. Now, you go, all right, the class width is 5, so then the upper end of this particular one is going to be what? 105? What's going to be the upper limit here? How many agree with Bridget? 105. How many aren't? Because you can tell by the way I'm asking the question. Katie can tell. What should it be? What's the upper limit?
134.
Not for this class. This class is only 5 wide. 104.
105.
Now, let's think about this for a second. How many data values, including 100 and 104, are there? 100, 101, 102, 103, 104, 5. Okay, so we actually count the 100. So when I go to 104, there's actually 5 possible values in there, which is good. Again, to the odd part of it, what's the middle? What value is in the middle of this? 102. So 102 is smack dab in the middle. Because I have 5 values, that odd number, I have 2 to the left, 2 to the right of that middle. So the midpoint of this class is 102. It is one of the, it could be one of these. I shouldn't say that it is. It could be one of these values. And by having that class width be odd, it ensures that the very middle of all the rest of these classes is going to be an integer. It will have the same decimal place as all of the data. And that's what that number 2 was saying. Okay? If the class width ends up being even, then there's going to be, let's say there were only 4 values, the midpoint is going to be a decimal compared to that. Okay, so that's why the idea of class width being odd is important. So when you get to a point of creating your own grouped frequency distribution, this is something you want to keep in mind, this value being odd, so that our middles, because one of the ways that we display these is with a graph, and it makes it easier when the midpoint, is the same decimal place as our data. Okay? So, here's the next part, and this is the thing, there's no overlap. It's mutually exclusive. Okay? So what I want you to do is I want you to finish making the class limits. There's going to be 7 of them all together. What's this value going to start with right here? 105. Okay? So go ahead and make the rest of the class limits. So we forced, because we divided by 7, you will run out of the values here when you go through and create all your different class limits. Be careful when you create your limits. Don't just add 5 every time. Okay, because we have to include both the first value and the last value. Now you're going to get to a place where you can add 5 and you'll figure out where, but don't just take the first number and add 5 to it. We've already proven that that doesn't work, right?
Does it work? Yes.
No, because what did I really add to 100 to get to the next one?
4.
I added 4. I added 1 less than 5. Because when we count 100 as the first value, that's why. Normally when we count, we don't count the 0. So that's why you go, okay.
I always count 0. So,
Alright, let's take a look, see if you had what I have. Okay. So it looks like, in your mind, this only looks like it's 4 apart. All of these only look like they're 4 apart. You're adding 5, so to speak, over here as you move up. Okay. Again, because we count the first number and we count the last number, there's really 5 in there. How many have that for your class limits? Okay. Again, class limits or intervals, same idea. Okay, the next thing we have to do is create the class boundaries. Okay, and the class boundaries are important if our midpoints are not the same decimal place as our data values. In this case it is, but we're going to create it anyway. Okay, and what we do to create our class boundaries is similar to how we created boundaries before, except we go below the first value and above the second value. So when we did boundaries in chapter 1, we took whatever our number was, we went down a half a tick and up a half a tick, depending on where our decimal was, right? So we're going to do the same thing here. Okay, what's down a half a tick from 100? 99.5. What's up a half a tick from 104? 104.5. That's going to be our boundaries, class boundaries, for this first interval. And then you're just going to keep working your way down and doing the same thing. So go ahead and come up with your class boundaries here. Boundaries, it will overlap somewhat. Okay? And again, why this is important is because that's only if the midpoint is not the same decimal place as the data values. If the midpoints of each interval if the class widths are even, that's when this is really gonna come into play. And it, even though it looks like in the table you're overlapping them, the data values won't actually overlap. Okay. Then once you're done, take a look at the screen and see if you got the same thing as me. So then here's what we do with this. So once we have, this is what I was talking about. There's a lot of work at the front end, and then the back end, it's tally and total. Okay? And that's all we're doing next. So what I want you to do now is take and tally and then come up with your frequency. The reality is, we're really not going to use this. Okay? You're putting numbers from 100 to 104 inclusively, and you're going to tally those up. Let me show you real quick what I was talking about before in terms of a way that I think will make it easier. So when I go up here and I start, and I'm just going to start right at the top, and I'm going to go with 112, and I'm going to put a little dot by it. So then I know I used it. I do not recommend drawing a line through it, because eventually you're going to need to see those data values again. Okay? So I know that 112 is between 110 and 114, so I'm going to put a tally mark there. I've essentially checked off 112, and now I can move on to the next value. So that's the way I would do it, is just to put a little dot next to the number that you've used, so you're sure you've used them all. Okay, and then go ahead and finish this up. And just FYI, that's the rest of the notes. The next slide will have all the tally marks on it. The next slide after that will have those frequency tally values added up. And then we just want to make sure that there's 50 in total when we're done. When we come up with a group frequency distribution, we do need to come up with the boundaries. In this case, we're not going to use the boundaries for anything, because the class width is odd. When we get to a place where the class width is even, we will use those boundaries, and we will use them for other visual representations of the data, which we're not doing in 2.1. Okay, I know you're not quite done, because this does take a little while, but we're going to run out of time, and I just want to finish up the slides. Just that way you can go back. I'll have this video uploaded here in a little while, so at least you can check when you finish if you did it right. Okay? So here's what my tally marks look like, and then my frequencies look like that. And just a quick little add them up. Okay? So I've got 10, 28, 41, 48, 49, 50. So I got them all there. Like I said, you don't necessarily have to put a total at the bottom, but it's a good place to check to make sure that you had everything there. Again, the work involved in creating the frequency distribution is not difficult, but it is often time consuming, okay, as you're starting to understand. Are there any questions about what we've gone over today? Again, this is a way of organizing our data so that we can begin to draw some conclusions about it. As we move through this chapter, we're going to look at different ways to display data. We're going to look at some graphs in the next chapter, different ways to represent the frequencies through different types of graphs. Okay?